Alright, welcome back one and all. So today what we're going over is going to be solving trigonometric equations. Basically, we're going to use trigonometric identities, which we have learned these past few weeks, and we're going to combine it with the algebra that we have been using basically our whole high school math career to actually find a value for x. Now, there's a few key things that you want to pay attention to when you're doing this. Number one is going to be the interval. So this gives us a very specific interval from 0 to 2 pi. And we're going to talk a little bit about what that means in just a second. But you have to pay attention to whether it says over the interval and it gives you a specific interval, or on the back it says for all real numbers. Let's start with over the interval, and then I'll get a little bit into what it means by all real numbers. So first things first, when we are going to start solving a trigonometric equation, we're going to treat this like any other like any other algebraic equation, where we're going to want to isolate x. So to isolate x, we first want to get all of our trig equations to one side. Since we only have the one sine of x and it's already on our left side, we can go ahead and skip that step for now. And then our next step would be to go ahead and add 1 to both sides. We are left with 2 sine of x is equal to 1. And then we go ahead and divide by 2 on both sides, which gives us sine of x is equal to 1/2. Now there are a couple ways to go about this next step. If you wanted to graph the graph of sine, the function of sine, which is this solid black line that you see here, and you wanted to graph y is equal to 1/2, which is this dotted line right here, you can very, very clearly see where it is that the two intersect. They intersect right here and right here. And since this is one of the practice problems, they go ahead and tell you that x is equal to pi over 6 here, and x is equal to 5 pi over 6. So right off the bat, you can say x is equal to pi over 6 and x is equal to 5 pi over 6. But they also give you some other values. They give you x is equal to pi over 6 plus 2 pi, x is equal to 5 pi over 6 plus 2 pi, minus 2 pi, minus 2 pi. How do you know which values you're actually looking for? Well, that's where this interval bit comes into place. This says from 0, which is going to be right here, to 2 pi, which is actually going to be right about here. So between the interval of 0 and 2 pi, there are only two intersections, pi over 6 and 5 pi over 6. So those would actually be your answers. X is equal to pi over 6, and x is equal to 5 pi over 6. Now, let's go ahead and pretend for a second that you did not have this graph here. What would you go ahead and use? There are two tools that I recommend that you guys use. The first one is going to be your trusty unit circle. Now, if you have a unit circle just like this one, you're going to go ahead and be able to look for where sine is equal to 1/2. Now you will remember that sine is equal to the y coordinate. So we're looking at just the y coordinates, and by looking here, I see that there's a 1/2 in the y coordinate at pi over 6, which is actually the first value that we got. If we keep going around and looking, we can see that there is another y coordinate with a value of 1/2 at 5 pi over 6. And so this is where our graph and our unit circle are going to correlate. If you guys remember, back in unit 4.2, and I should have given this back to you, we went ahead and filled out this chart full of reference angles, full of trigonometric equations. And if we look at where sine is, then we see that sine is equal to 1/2 at pi over 6, and sine is equal to 1/2 at 5 pi over 6. These should all match up. The one drawback to this particular chart is that it only goes from 0 to pi. And so if you're looking from 0 to 2 pi, you have to remember to keep going or look elsewhere or double your values or anything like that, because you won't be able to see the full expanse of the unit circle on here. You only get half of the unit circle written out here. So I would just be careful with that. Now let's pretend for a second that they didn't ask us about this interval here. They asked us instead to solve for all real values. So we're just gonna separate that real quick. And let's say that they asked us for all real values. In that case, what you would do is that you would actually take your first value, which is pi over 6, and you would add 2 pi times n. Now let me explain to you where that comes from. If I'm here at pi over 6, is it not true that I could make one full rotation about my unit circle and end up at the exact same spot? Just like when I make a full rotation or a full cycle, I end up at the exact same spot. It's definitely true. Now, how many of these can I make? How many cycles can I take? How many rotations can I make? There's an infinite amount I can make. That's where this n comes into place. This n just means any integer. So use n to represent any integer, whether it's positive, whether it's negative. As long as it's a whole number, you are able to go ahead and use this as a replacement for any value of terms, any number of terms. So if we have pi over 6 plus 2 pi n, then similarly 5 pi over 6 plus 2 pi n is what this will be for the interval of all real numbers. All real numbers. Now, knowing that and getting a little bit of a warm-up, let's go ahead and try out something like number 2. In the case of number 2, we're going to require a little bit of factoring. Now, our first step is going to be to get to get all of our trigonometric equations to one side. In this case, I'm going to want to move them over to the left. So I'm going to take sine squared x minus 2 sine of x, and I'm going to equal this to 0. My next step is going to be to look at this very carefully and think, okay, if I was solving this like any other algebraic expression, and I saw that I had a squared and I saw that I had an x, my next logical thought would be to actually factor out an x, or in this case, a sine of x. So I'm going to actually go ahead and do that. I'm going to factor out a sine of x, and when I factor out a sine of x of sine squared of x, I get just sine of x. And when I factor out sine of x from negative 2 sine of x, I just get a minus 2. And this will all be equal to 0. Now that I have this factored out, I can go ahead and equal either of these, or actually both of these, to 0 to make my equation true. So I'm going to take sine of x is equal to 0, and I'm going to take sine of x minus 2 is equal to 0. Let's go ahead and try this guy first. I'm going to add 2 to both sides. I get sine of x is equal to 2. And when I look at my unit circle, or when I look at my reference chart, or when I graph this, I see that there is absolutely nowhere where sine of x is equal to 2. So in this case, there would just be no solution. Let's see if we have better luck with sine of x equal to 0. Sine of x equals to 0, we look at our y value for our coordinate points. We have a y value there and a y value there. We can see that at 0 and at pi, well, more specifically, x is equal to 0 and x is equal to pi, we have a value for sine of x is equal to 0. It's also true that when x is equal to 2 pi, we have a sine value of 0. So all of these will work. You can actually say that sine of x will be equal to 0 whenever x is equal to pi times n, because realistically, whenever you multiply pi times any whole number, whether it is positive or negative, or even 0, you're going to get a correct answer. For number 3, we are going to try something a little bit different. In this case, we have cosecant. Now, cosecant, if you will notice, will not show up on your unit circle. It will, however, show up on your reference chart. So if you want to go ahead and use this, you have one of these available. You are going to be allowed to use this for this assignment. But let's see how we would tackle this if we did not have this chart readily available. We would go ahead and start, just like any other equation, by isolating our x. We're going to take cosecant squared of x is equal to 2. And I will then take the square root of both sides. So I end up with cosecant of x is equal to plus or minus the square root of 2. You don't want to forget about the plus or minus whenever you take a square root. And from here, we're going to use some of our trigonometric identities that we learned last class. So if cosecant of x is equal to 1 over sine, and sine of x is equal to 1 over cosecant, then sine of x will be equal to 1 over plus or minus the square root of 2. We don't ever want to leave a radical at the bottom of a fraction in the place of the denominator, so we're going to go ahead and multiply this by the square root of 2 over the square root of 2, which ends up giving us the square root of 2 over 2. Now, if we look at our unit circle, we can actually find out where that is. We didn't have cosecant, but we do have sine, where sine is the square root of 2 over 2. And we are looking for plus or minus, so either one will work, either a positive square root of 2 or a negative square root of 2. So we can actually see one right there, right there, right there, and right there. So we have all these different solutions. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, because they're asking us to solve on the interval 0 to 2 pi, this is technically enough to get the answer to this problem. But let's say that we didn't have to worry about the interval. Let's say that they were asking for all real numbers. What we would go about doing now is we would take a very hard look at our unit circle. In fact, I'm going to go ahead and circle the values that we're using. So if we take a look at pi over 4, while it's true that we could go one full rotation and end up at the same spot, it's also true that we could just go half a rotation and end up on an acceptable answer, the negative square root of 2 over 2. So instead of saying something like pi over 4 plus 2 pi n, 3 pi over 4 plus 2 pi n, 5 pi over 4 plus 2 pi n, 7 pi over 4 plus 2 pi n, we can actually just go ahead and take care of this pi over 4 and this 5 pi over 4 by saying pi divided by 4 plus pi times n, pi being half a rotation. So if we go half a rotation, or 2 halves, or 3 halves, we would end up at acceptable answers. We can also say 3 pi over 4 plus pi times n. So x would be equal to 3 pi over 4 plus pi times n. For the exact same reason, we could start here and go half a rotation, and then another half rotation, and then another, and so on and so forth. Question number 4, I'm going to leave to you guys, but just know that once you have it factored out this way, you have two terms that you're multiplying together. If you equal either of these to 0, then you should be able to get your answers. Now, because you're using tangent, I recommend that you use your chart and not so much your unit circle, because it will not be as easy to see on the unit circle. But I'm sure that if you don't have your chart handy, you can manage with the unit circle by going ahead and dividing your sine divided by your cosine. Let's take a look at this one. Now this one's interesting because we have two types of trigonometric equations. We have both sine and cosine, very specifically sine squared. When I have two different types of trigonometric equation, my first instinct is going to be to go ahead and solve this trigonometric equation in a way that I will only have one type. In other words, I know that sine squared is actually equal to 1 minus cosine squared of x, and everything else will remain the same. Now from here, I'm going to go ahead and distribute this 2 inside. So 2 minus 2 cosine squared of x plus 3 cosine of x minus 3 is equal to 0. Ladies and gentlemen, and now what I'm going to do is I'm going to go ahead and combine any like terms that I have. So I have that and that. I have two constants that I can go ahead and combine, and I'm going to leave that as negative 2 cosine squared of x plus 3 cosine of x minus 1 will equal to 0. What I have left here is a quadratic equation. Quadratic equations, we should be familiar about how to factor them, but if you are not sure how to go about doing this, your first step is always going to be to make sure that your a is positive. So I'm going to make sure my a is positive by dividing both sides or multiplying both sides by negative 1, just so that everything will switch signs and my a will be positive, making it easier for me to work with. I will have 2 cosine squared of x plus 3 cosine of x minus 1 is equal to 0. 0 doesn't change, it's neither negative nor positive. Now let's take a look at this and see if we can't, oh my apologies, this should be negative 3 and this should be positive 1. Let's take a look at this and see if we can't figure out how to factor this. Now if this were a regular algebraic function without any sines or without any cosines or anything like that, without any trigonometric identities, you would go ahead and multiply your a times your c. And remember, when I say ac, I'm talking about ax squared plus bx plus c. You would want to go ahead and multiply your a times your c and figure out what factors of that product will add up to your b. And so if I multiply positive 2 and positive 1, the answer will be 2. And what are the factors of 2 that add up to negative 3? Well, that's actually a negative 2 times a negative 1. These will both add up to negative 3. So I'm going to go ahead and separate my equation like this. 2 times the cosine squared of x minus 2 cosine of x minus 1 cosine of x plus 1 is equal to 0. The reason I did this is so that now I can go ahead and separate both halves of my equations, and I'm going to focus on this one. I said I'm going to focus on this side and try to factor something out. In this case, I can factor out a 2 cosine of x from both terms, and that leaves me with cosine of x minus 1. Now my goal is to factor something out of here so that what's left over is equal to cosine of x minus 1. And that is negative 1. Negative 1 factored out of this gives me cosine of x minus 1 is equal to 0. Since both these terms are equal, I can actually combine 2 cosine of x minus 1 times cosine of x minus 1, and both these guys equal to 0. Now I know it's a long process, but bear with me. Now your next step is going to be to actually equal this side to 0 and equal this side to 0. I can tell you right now this is going to be cosine of x is equal to negative 1/2, and cosine of x is equal to positive 1. So once again, we take a look at our unit circle, and we look at where cosine is equal to 1 and cosine is equal to negative 1/2. Cosine being our x. So I see a 1 right here. That's going to be 0. And I also see a negative 1/2 at 4 pi over 3 and a negative 1/2 at, oh, I must have missed it, 2 pi over 3. So that will actually be both our answers. X is equal to 0. X is equal to 2 pi over 3. And x is equal to 4 pi over 3. Now these top parts, or these three top these top three problems you're going to solve in much the same way as you did the last one. These bottom ones are a little different though, so I wanted to quickly go over them. In the case of sine of 2x is equal to negative 1/2, what you're going to want to do is you're going to want to go ahead and not worry about what's inside your parentheses until the very end of your problem. In fact, I would say that you can actually go ahead and substitute this 2x with any letter you want. Let's use, for example, u just for this example. Like I said, you can use any variable that you want. So we're going to say the sine of u is equal to negative 1/2. Now, if we look at either our unit circle or if we look at our chart, we can see that the sine of negative 1/2 has a couple of values. We have 7 pi over 6 and we have 11 pi over 6. So in this case, u is equal to 7 pi over 6 and u is equal to 11 pi over 6. Now we can't stop there because it's asking for all values. So all real values, meaning that we have multiple number of terms. So we can say plus 2 pi n plus 2 pi n. Now when we're at this point, we can actually turn back our u into 2x. So now we have 2x is equal to 7 pi over 6 plus 2 pi n, and 2x is equal to 11 pi over 6 plus 2 pi n. And we can actually go ahead and divide the whole thing by 2. So we can actually say 7 pi over 12, these 2's will cancel out, plus pi n, and that's what x is equal to, and x is equal to 11 pi over 12. Now somebody asked me, how did I get 12? Well, if you take 11 pi over 6 divided by 2, and you multiply this by the reciprocal, that's just 1/2. And when you multiply straight across, that gives you 11 pi over 12. So anyway, 11 pi over 12 plus pi, because we divided this whole thing by 2, and those two cancel out, plus pi times n. And so there you have it. It's nothing too difficult. It's just combining algebra with trig identities, which you guys have seen before. Let me know if you guys have any questions. Thank you.